Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Yes. You're still welcome again. I'm going to take you on chemical formulae and equation part 3. Remember, we've done part 1, part 2, and part 3. That's why I said you should follow up the lesson simultaneously as it goes. Now, by the end of this lesson, you will be able to know how to find percentage mass of an element in a compound, how to find the empirical formula of a compound, and the difference and similarities between empirical and molecular formula. Now, percentage composition. Percentage composition is the relative mass of each element in a compound. In essence, before you make an element, before you make a compound, there must be a composition of elements. These elements will bring their things together. They bring their number of atoms, they'll bring their mass numbers, they'll bring everything about them to combine to form a compound. In essence, in the compound, like I said, the elements are not scattered. The elements are not scattered. They still maintain their composition. They still maintain their percentage. They still maintain their atomic numbers. So in essence, these are the things you're going to calculate. You know, their percentage they gave out to form the compound. Now, what is percentage mass of an element in a compound? The mass percent is the mass of an element in a compound expressed as a percent of the total mass of that compound. The mass percent is the mass of an element in a compound expressed as the total percent of the total mass of that compound. How many percent does this element give out in the total mass? Like, for example, you want to cook a goosey soup now, okay? How many percent will the Maggi give to make the full soup? In this total soup, how many percent did Maggi give? If the soup is 75%, okay, how many percent did Maggi give to make the soup 75%? These are the things you're going to calculate. How many percent did the element give to make the total mass of the compound? Remember, percent is 100. So how many percent did he give? How many percent did the element give to make 100% of the total compound? Now, we said how to calculate mass percent of an element in a compound. Okay, they say you divide the mass of the element in 1 mole of the compound by the compound's molar mass, then multiply the result by 100. You divide the mass of the element in 1 mole of the compound by the compound's molar mass, then multiply the result by 100. What do they mean? Now, the mass number of the element you're looking for, okay, the mass number of that element, okay, you're looking for. When you add the molar mass of the compound, the mass of the compound, the mass of each element in the compound, when you add them together, you now divide it by the mass number of that element you're looking for. Remember, it is moles. Every element brought out a mole to form this compound. In essence, the compound has moles, different types, different moles. Hydrogen is a mole, oxygen is a mole, and nitrogen is a mole. So you divide the mass of the element, that particular element you're looking for, by the compound's molar mass. Then you multiply what you got by 100 to get the percentage. So now we are going to check a question. They say calculate the percentage by mass of oxygen in trioxonitrate 5 acid, HNO subscript 3. And they gave you H as 1, N as 14, and O as 16. Remember, these things are given to you are the mass numbers. Okay? They are the mass numbers. Now they said divide the mass of the element in 1 mole by the compound molar mass, then multiply by 100. First of all, we are going to look for the compound's molar mass. Already you know the mass of the element you're looking for. Now, you are going to look for the compound's molar mass first. Then, you now divide it by the mass of the element. Now, the compound molar mass is, we are going to, remember molar mass is the sum of all the masses in the compound. It's the sum of all the molar masses. Okay? The sum of all the mass numbers in the compound. The molar mass is the sum of all the mass numbers in the compound. Already we know that. So therefore, we are going to start now. Compound's molar mass. Compound molar mass is equal to 1 times H plus 1 times 14 plus 3 times, okay, 1 times H plus 1 times N plus 3 times O, which is oxygen. Why we got 3 there, you already know that 3 is a subscript. And you multiply the subscript by the mass number of the element. I'll give you the molar mass of the element. Okay? Now, when you multiply 1 times H, why? Because H is 1. And in the compound, H is still 1. Nitrogen is 1. And the compound nitrogen is still 1. Now, the mass number of nitrogen is 14. The mass number of oxygen is 16. Now, if you check in the compound, oxygen has 3 atoms. Oxygen has 3 atoms. So in that sense, you multiply the number of atoms by the mass number. Nitrogen has 1 atom. You multiply the number of atoms by the mass number, which is 14, and hydrogen has 1. You multiply it, which is 1. So coming to this, it will give you 1 times H, which is equal to 1 times 1 plus 1 times 14 plus 3 times 16. Now 1 times 1 is 1 plus 14 plus 48. 32 plus 16, 48. So it will give you 1 plus 14 is 15. 15 plus 48 is 63. So you now know the compound's molar mass as 63. You now know the compound molar mass as 63. If you watched the previous lesson, you will know why this thing is like this. But I'll still explain. Why we bring the mass like this is because the molar mass, like I said, is the sum of all the masses in the compound. Okay? Now, H is 1. And the mass number of hydrogen is 1. The mass number of nitrogen they gave you as 14, and the mass number of oxygen they gave you as 16. Now, for you to find the molar mass, let me repeat myself like I said last time, if there is the number of atoms added to the element, you multiply the number of that atom with the mass number that they gave to you. You multiply the number of that atom with the mass number, and it's going to give you the molar mass of that element. So in essence, they say divide the mass of the element in 1 mole. In essence, 1 mole of oxygen here is 48. Okay, so now we've got the compound molar mass at 63. Now they said find the percentage by mass of oxygen. In essence, therefore, percentage by mass of oxygen will be equal to. Now, they said divide the mass of the element in 1 mole of the oxygen. Now, what is the mass of oxygen? The mass of oxygen they gave to you is 16. The mass number is 16. The mass number is 16. So in essence, the mass number will be 16. They say divide it by the compound molar mass, which is 63, then multiply by 100. 63 multiplied by 100. So it is going to give us 25.39%. 25.39%. If you use a calculator, to 29.39% or 25.4, approximately 25.4%. Any of the two answers is correct. Now, like I said, this is how to calculate percentage by mass. How to calculate percentage by mass of an element in a compound. This is how to calculate percentage by mass of an element in a compound. If they give you a question like this, you just have to solve the way I gave to you accordingly. Now, the next question, if you look at it very well, like I said, you have to follow up accordingly. Okay, calculation are being marked by steps. Every step you take has a mark. Every step you take has a mark. Now, let's look at the next question. I hope you're understanding and you're following. Let's look at the next question. Now, the next question says, calculate the percentage by mass of all the component elements. Calculate the percent. Calculate the percentage mass of all the component elements in sodium trioxocarbonate. Sodium trioxocarbonate 4. Okay? Sodium carbonate 4. NaCO3. They gave you Na as 23. C as 12, and O 16. Now remember, you're going to look for the compound molar mass, as we did. Then you start calculating one after the other. It's a very simple thing when you follow the step. Okay? When you follow the step and you listen concurrently and attentively, you're going to understand it. It's very simple. It's not hard. Now, let us know the compound molar mass first, because the rule says divide the element by the compound molar mass. So before you divide that, you must already know the mass of the element you want to use. They said calculate the percentage mass of all the component elements. You've known the masses of the component elements already. What you don't know is the compound molar mass. What you don't know is the compound molar mass. So you find the compound molar mass first again. Now the compound molar mass will be, like we said, solution, molar mass of compound. molar mass of compound, Na, okay, will be 1 times, okay, sorry, is N subscript 2 CO3. N subscript CO3. Now, it will be 2, if you check the sodium has 2 atoms. So, in essence, it has 2 moles in the compound. In essence, that's 2 moles in the compound. So, it will be 2 times Na plus 1 times C, which is carbon, plus 3 times 16. You already know why, because oxygen here is 3. So you must have to times that 3 by its mass number. That 3 represents the number of atoms in the molecule, in the oxygen. So in that context, the number of atoms will be multiplied by the mass number to give you the molar mass. Okay? Now, everything we multiply by the mass number to give you the molar mass. I gave you the steps on calculating molar masses. Now, 2 times sodium, it will be 2 times 23 plus 1 times 12 plus 3 times 16 plus 3 times 16. This is 3 times oxygen, 3 times O. So now it will be 2 times 23, 23 times 2, 23 times 2 is 46, plus 12, plus 48. Plus 12 plus 48, which is going to give us 12 plus 48 is 60. Okay? 60 plus 46 is 106. 60 plus 46 is 106. So we've come to know the compound molar mass as 106. So now they said calculate the percentage mass of all the component elements in sodium triosonitrate. Now we are going to pick each element and calculate the percentage. We are going to pick each element and calculate the percentage. Remember, the compound molar mass is 106. The compound molar mass is 106. So now, compound molar mass is 106 now. So now, percentage, 106. Now, they said every component element, let's start with sodium. Percentage of sodium will be equals to divide the mass of the element of the compound by the molar mass. So the mass of the element will be 23 divided by 106, which is the compound's molar mass. Whether the compound molar mass by 106 times 100. 23 divided by 106 times 100. Let us know what it gave to us. This is for sodium. Okay? This is for sodium. (106), okay, times 100. It gave us 21, which equals to 21. Give us 21.698%. 21.69%. 21.69%. Or you can see, say, 21.7%. Anyone you use is correct. So for sodium, we've gotten 21.69%. Or 21.7%. That is for sodium. That is for sodium. Now, the next one is for carbon. Percentage of carbon, which is C, will be 12 divided by 106 times 100, which is equal to, it's a very simple thing. Okay? 12 divided by 6 12 divided by 106 12 divided by 106 times 100. It gave us 11.32%. 11.32%. Now this is the percentage for carbon. This is the percentage for carbon. Now, percentage for oxygen. Percentage for oxygen will be equal to 16 divided by 106 times 100. 16 divided by 106 times 100. 16 divided by 106 times 100. It gave us 15 equals to 15.09%. 15.09%. So in that context, oxygen, percentage for oxygen is 15.09%. Percentage for sodium is 21.69%, and percentage for carbon is 11.32%. 11.32%. So therefore, oxygen is 15.09%, carbon is 11.32%, and sodium is 21.7%. Remember, we said the compound molar mass is 106. 106. And the rule says divide every single mass number of the element by the compound molar mass. Then multiply the result by 100. Okay? Now, this is how you calculate percentage mass of elements in a compound. Okay? You divide the mass of the element in 1 mole of the compound by the compound's molar mass. Divide the percentage of 1 mole of the compound by the compound molar mass. As you can see, we divided we first of all added all the masses of the compound. First of all, added all the elements in the compound to make up the mass of the compound, to make up the molar mass of the compound. Then, we now started using the mass number of each element in making our calculations according to the rule to calculate mass percent of an element in a compound. Like I said, the first thing they said, you first of all look for the compound's molar mass by adding the masses of the elements. When you add the masses of the element together, the molar masses of the element together, the mass numbers of the element together, they will give you the compound's molar mass. Then you start using the individual mass of the element in making your division. Then you multiply the result by 100. Now the next one is empirical formula. Empirical formula. An empirical formula is the representation of whole number ratio of various atoms present in a compound. In essence, the number, okay, the number of atoms that the element gives for the formation of a compound is the empirical formula. When it's being represented in the compound, it becomes the empirical formula. It must have to be represented. Take, for example, the number of atoms that is being present in water of hydrogen is 2. So in essence, the empirical formula can be calculated from that. Now, it must have to represent the whole number ratio. You know, ratio are division. But it must have to be in a whole number. It must not have to be in ratios. And that ratio, that whole number ratio of atoms that is being represented by the element in the compound is called empirical formula. Now let's see how we are going to solve empirical formula. Now, rules on finding empirical formula. They say change the percentage to grams. The percentage of atoms that the element gave to form this compound will be changed to grams first. Okay, the percentage will be changed to grams. Then the second one, they divide all the masses by their molar mass. Now, the masses means you're dividing all the grams by their molar mass. Okay, the given masses. When you change this thing to grams, that gram represents the mass. Why? Because grams talks about masses. So the mass of the element that you have already converted to will be divided by their molar mass. Then pick the smallest answer in moles from the previous step and divide the answers by that. What do they mean? When you divide these masses by their molar mass, you must definitely get an answer, a small answer. Remember, you're dividing each element. You're bringing out each element. Each element, that's what they said. So when you divide each element by their molar masses from the given mass, you will get a smallest answer. Definitely, the answers will not be the same. Let's take, for example, hydrogen cannot be the same answer with oxygen. So the smallest answer you get by that division, you use it to divide all the answers you get by that. Then the coefficients calculated in the previous step becomes a subscript to each element in the chemical formula. The coefficient means the number, the answer. Okay, that integer you got, okay, becomes the subscript of each element. When you divide the molar masses by the smallest answer, when you divide the molar mass by the smallest answer, you get a number, you get an answer. Now that answer becomes the subscript. That answer becomes the number of atoms to the element you calculated it from in the chemical formula. Now let's see a question on this, following the rules of empirical formula. The question says, a compound was found to contain 32.65% sulfur, 63.3% oxygen, and 2.04% hydrogen. What is the empirical formula of the compound? What is the empirical formula of the compound? What is the empirical formula of the compound? Remember, they say change the percentage to gram. Solution. Now, sulfur has 32.65%. Okay? Oxygen has 63.3%. And hydrogen has 2.04%. Step one. Now they say change the percentage to grams. Change the percentage to grams. The change the percentage to grams is just change the sign percent to grams. Finish. Change the percentage to grams. That's what they told you. Now the sign of the percent will be changed to grams. In essence, sulfur will be equal to 32.65 grams. Oxygen will be 63.3 grams. And hydrogen will be 2.04 grams. Finish. What you're changing is just the sign of the percentage to grams. That's all. What you're changing is just the sign of the percentage to grams. Now, step 2 says, divide all the given masses by their molar mass. Divide all the given masses by their molar mass. Now, what is the mass of sulfur? Mass of sulfur is 32. Mass of oxygen is 16. And mass of hydrogen is 1. Mass of sulfur is 32. S is equals to, mass of sulfur is 32. Mass of oxygen is 16. And mass of hydrogen is 1. In essence, the mass of sulfur will be equal to 32.65 divided by 32. They say divide all the given masses by their molar mass. I told you that the mass of sulfur, is 32. Okay? Mass of oxygen is 16. And mass of hydrogen is 1. And they said, divide all the given masses by their molar mass. Now, the molar mass of sulfur is 32, the mass of sulfur. Mass of oxygen is 16, and mass of hydrogen is 1. So now, when they said, for sulfur, it will be 32. That is the mass. Divide all the given masses. The given mass is sulfur is 32.65. So you're going to divide 32.65 by the molar mass of sulfur, which is 32. By the molar mass of sulfur, which is 32. Now, let's know what it gives us. 32.65 divided by 32. 32.65 divided by 32, it gave us 1.02. 1.02. It gave us 1.02. That's for sulfur. Now, for oxygen, O is 63.3 divided by 16. That is the molar mass. The molar mass of oxygen is 16. And they say divide all given masses by their molar mass. Now the given mass of oxygen is 63.3. And the molar mass of oxygen is what? 16. So you are dividing 63.3 divided by 16. 63.3 divided by 16. It gave us 3.95. 3.95. Give us 3.95. Now the last one is hydrogen. Last one is hydrogen. Hydrogen is 2.04. 2.04. And the mass is 1. And it gave us 2.04. Now we have divided all of them by their molar masses. That's step 2. All of them by their molar masses. Now, step 3. Step 3. Step 3 says, pick the smallest answer in moles from the previous step and divide all the answers by that. Now, the smallest answer is 1.02. The smallest answer is 1.02. Now, you're going to divide all the answers you got by that. So, for sulfur, it will be 1.02 divided by 1.02. And it's going to give us 1. For sulfur, it will be 1.02 divided by 1.02, and it's going to give us 1. In essence, sulfur is 1. Now for oxygen, it's going to be 3.95 divided by 1.02. 3.95 divided by 1.02. 3.95 divided 1.02. divided by 1.02. Oxygen is going to give us 3.95. Going to give us 3.87. 3.87. Now for hydrogen, it will be 2.04 divided by 1.02. It will be 2.04 divided by 1.02. (2.04) divided by 1.02. And hydrogen will give us 2. Now, we have gotten every answer. We have gotten every answer. Now, the last step says the coefficients calculated in the previous step becomes a subscript to to each element in the chemical formula. Now, this is step 3. This is step 3. Now, the step 3, sulfur is 1. Sulfur is 1. Oxygen is 3.87, and hydrogen is 2.04. Now, there is a rule in the empirical formula. They said it's a simple whole number ratio. It's a simple whole number ratio. It's a simple whole number ratio. Now, in essence, it cannot be in a decimal. It cannot be in a decimal. So every single, if your answer, take note, NB, if your answer is in decimal, you convert it to the nearest whole number. If your answer is in decimal, you convert it to the nearest whole number. Now, if you check, sulfur is 1. Sulfur is 1. Oxygen is 3.87. In essence, we have a point here. We have a point here. So you're going to convert it to the nearest whole number. And converting it to the nearest whole number will give us oxygen as 4. Then hydrogen is 2. Hydrogen is 2. Now, the last one is step 4. Step 4. Let's know where we're going to do step 4. Step 4. Sulfur is 1. Step 4. Oxygen, like I said, will be converted to the nearest number, which is 4. And hydrogen will be converted, which is 2. Now, the answers we got are sulfur is 1, oxygen is 2, and hydrogen is 2. Now, they said the coefficient calculated in the previous becomes the subscript of each element. It becomes the subscript of each element. In essence, hydrogen will become step 5. Hydrogen will become 2, sulfur will become 1, and oxygen will become 4. Hydrogen will become 2, sulfur will become 1, and oxygen is 4. This is our answer. This is the empirical formula of that question. H subscript 2, SO subscript 4. That is the answer. H subscript 2, SO subscript 4. That is the answer. H subscript 2, SO subscript 4. That is the answer. Like I said, why we use 4 for oxygen is supposed to be 3.85. The rule of empirical formula says that if the number, take note, if the number is in decimal, you convert it to the nearest whole number. Because I said it is the whole number ratio. In essence, it's not supposed to be in decimal. Decimal is division. If they say 0.2, that means to say it's 2 over 10. And 2 over 10 is a ratio. That ratio means 2 is to 10. If they say 0.2, okay, it means 2 over 10. And that 2 over 10 is a ratio because the ratio there is 2 is to 10. 2 ratio 10. That is 2 over 10. And 2 over 10 is 0.2. So if the answer is in decimal, in essence, the answer is in ratio. No. This one telling us that is a whole number ratio. So if the answer is in decimal, it will be converted to a whole number. So now oxygen becomes 4. Hydrogen becomes 2, and sulfur becomes 1. So our answer of the empirical formula is H subscript 2, SO subscript 4. Now let's take another question from this. Let's take another question. The last question for this. So that you're going to understand what you're doing. Okay? You look at the solving and you see every step accordingly. Step 1, step 2, step 1, step 2, step 3, step 4, and step 5. You see how the steps are being taken. So you follow up. Now, let's take the next question. Let's take the next question. The next question says, when 0.273 grams of magnesium is heated. Is heated in a nitrogen gas. Is heated in nitrogen. In nitrogen environment. A chemical reaction occurs. The product of the reaction is product of the reaction is 0.378 grams. Calculate the empirical formula. Calculate the empirical formula. Now, remember I told you the empirical formula, the percentage will be changed to grams. In essence, you must first look for the mass of the elements. You will look for the mass of the elements. Now, the product of the reaction is this. Now, see the total mass of the product. Now, they say the total mass of the product is 0.378. Total mass of the product. Total mass is 0.378. Is 0.378 grams. That's the total mass. In essence, the total mass of all the reaction is 0.378 grams. Now, you know the grams of magnesium. You know the grams of magnesium, but you don't know the grams of nitrogen. Because before you solve empirical formula, it must have to be in grams. It must have to be in grams. Okay? The number must have to be in grams and not in percentage. Because you follow the rule, they say change the percent. If it's in percent, you must have to change it to grams. Now you're going to find, now the only thing you got there is the number of grams of magnesium. You do not get the number of grams of nitrogen. In essence, nitrogen, for you to get the grams of nitrogen, you must have to minus the number of magnesium from the total product. This is the total product. Okay? Now they said the total product of magnesium is heated in nitrogen. In essence, magnesium, the grams of magnesium and the grams of nitrogen must have to give you the total mass of 0.378. That is it. You must have to give total mass of 0.378 because they say when this is heated in this, in essence, this must have to add to hydrogen. And the reaction, the total mass, the product must have to give it this. So now, mass of nitrogen, you must try to look for the mass of nitrogen, will be equal to 0.378 minus the mass of magnesium, which is 0.273. Which is 0.273. And the answer is 0.105 grams. So if you add 0.105 grams to 0.273, it will give you 0.378. In essence, you have known the mass of nitrogen. So the mass of nitrogen plus the mass of magnesium will give you the product of the reaction, which is 0.378. Now, the percentage, they say change the percentage to grams. In essence, the empirical formula must have to come with percentage that you will change to grams. The empirical formula must have to come to percentage that you change to grams. The empirical formula comes with percent, okay, that you change to grams. Now you've gotten the grams. Now what is the percentage of nitrogen? Percentage of nitrogen will be the mass of nitrogen divided by the mass of the product multiplied by 100. So it will be 0.105 grams divided by 0.378 times 100. Times 100. Percentage of nitrogen times 100. And it will give us 27, will be equals to 27.77%. 27.77%. Now you've gotten the percentage of nitrogen. Now the percentage of magnesium will be 0.273 divided 0.378 times 100. And it's going to give us 72.23%. 72.23%. Now, we have gotten the percentage of nitrogen and magnesium. Like I said, the first that I said, when 0.237 grams of magnesium is heated in nitrogen environment, a chemical reaction occurs. The product of the reaction is 0.378. In essence, adding magnesium and nitrogen together, the masses, the product will give you 0.378. So first of all, you have to look for the mass of nitrogen. Now we got the mass of nitrogen at 0.105 grams. Because the mass of nitrogen will be the product minus the magnesium. It's a simple thing. If they tell you in mathematics that 3 minus A is equal to 7, therefore A will be equal to 7 minus 3. If they tell you in mathematics, that 20 minus A is equals to 2. 20 minus A is equals to 2. It's a simple thing. A will be equals to 2 plus A. 20 minus A is equals to 2. If they tell you mathematics that 20 minus A is equal to 2. Okay? A will be equals to 20 minus 2, which is 18. Which will be 18. So it will be 20 minus 18 is 2. So now they've given us the product as 0.378. That is our 20. That is our 20, assuming. And the A there is the magnesium. The A there is the nitrogen, sorry. And the answer is 0.73. So when you want to get the nitrogen, you must have to minus the magnesium, the figure that is given, minus it from the answer, minus it from the product, minus it from what they gave you to do. So now we got our mass of nitrogen by minusing magnesium from the product that is being formed. In essence, it's going to be 0.378 minus magnesium, because 0.378 is the answer that is supposed to be given when you add magnesium and nitrogen. So for us to get nitrogen, we must have to remove magnesium from the answer, and it gave us 0.105 grams. Now when you finish, you must have to look for the percentage of nitrogen. Remember, empirical formula rule says change percentage to grams. In essence, the question, the figures, the integers given must be in percentage. That is when you can change it to grams. So now you've gotten the grams, then you change to percentage. Now nitrogen is 27.77% and magnesium is 72.23%. Now you cannot solve your empirical formula. You cannot solve your empirical formula. Now let's solve the empirical formula. Step 1, solving empirical formula. Solving the empirical formula now. Step 1. Step 1 says change the percentage to grams. Nitrogen has a percent of 27.77. So it will be changed to grams. I told you just remove the percent and you get it. So step 1, nitrogen will be equal to 27.77 grams. And magnesium will be equal to 72.23 grams. Step 2. The percentage is changed to grams already. The percentage is changed to grams already. Now, percentage is changed to grams already. Now, if you check, you've changed the percentage to grams, because the percentage of nitrogen is 27.77 and the percentage of magnesium is 72.23%. Now the step 1 says change the percentage to grams. The percentage has been changed to grams already. Now they say divide all the masses by their molar mass. Now the mass of nitrogen is 14 and the mass of magnesium is 24. The mass of nitrogen is 14 and the mass of magnesium is 24. Sorry, in the question that they will give to you in the empirical formula, they are going to indicate the masses of the element for you. When the question comes, they are going to indicate the masses of the element for you. I really don't indicate it because I already know. So, but in case they did not indicate it for you, I have already told you that the mass number is times 2 of the atomic number. The mass number is times 2 of the atomic number. And the atomic number is the rule they used in placing the elements in the periodic table. So if hydrogen is 1, then the mass number is 1. 1 times 1 is 1. If hydrogen is 7, then the mass number is 14. If carbon is 7, then the mass number should be 14. If carbon is 6, the mass number should be 12. Okay? If magnesium is 12, then the mass number should be 24. Mass number are basically, like I said, times 2 of the atomic numbers. An atomic number is the number that is being placed in the periodic table. How they place elements in the periodic table identifies the atomic number. The number the element occupies in the periodic table is the atomic number. So you just times it by 2. Okay? Just times it by 2. So now, nitrogen occupies a space in the periodic table as 7. So its mass number is 14. Magnesium occupies a space in the periodic table as 12. So the mass number is 24. Now, we have changed the percentage to grams already. Now the step 2 says divide all the masses by the molar mass. Now the molar mass of nitrogen, like I said, nitrogen will be equal to 27.77 divided by 14. 27.77 divided by 14. So the answer is 1.9. 1.98. Okay? The answer is 1.98. Then magnesium will be 72.23 divided by 24. Divided by 24. Remember, we are dividing it by their mass numbers. We are dividing it by their mass numbers. So it will be 72.23 divided by 24. Divided by 24 is 3.0, is 3. 24 is 3. So it's 3.009. Or let's say 3.009 will be 3.01. 3.01. Now we've gotten our step 2. We've gotten our step 2. So nitrogen is 1.98, magnesium is 3.01. That's why I say pick the smallest. The smallest of both of them is 1.98. If you check the numbers, the smallest of both of them is 1.98. Now this is step 3. Step 3. Step 3. Nitrogen will be equal to 1.98 divided by 1.98 is equal to 1. And magnesium will be 3.01 divided by 1.98. 3.01 divided by 1.98. It will give us 1.52. 1.52. Now, nitrogen is 1, and magnesium is 1.52. Nitrogen is 1, and magnesium is 1.52. So, nitrogen is 1. So, nitrogen is 1, and magnesium is 1.52. Now, if you check the rules, they say the coefficients calculated in the previous step become the subscript. And I told you that since magnesium has a decimal point, I told you that it's going to be converted to the nearest whole number. It's going to be converted to the nearest whole number. It's going to be converted to the nearest whole number. Now, converting to the nearest whole number means magnesium is 2 and nitrogen will be 1. Because 1.52 conversion is 2 and nitrogen will be 1. So it will be equal N, which is 1. The N is 1. Mg subscript 2. Because you're going to convert this to 2. Okay? So N is equal to 1. And magnesium is equal to 1.52, which is equal to 2. That's the conversion. So when we convert this, it will give us N, nitrogen 1, and magnesium will be 2. That is the empirical formula of this particular question. That's the empirical formula of this particular question. Remember, I told you that it is a simple whole number ratio. That is why we do not leave our answers in ratios, in decimals. Decimals are ratio, like I said, is going to be converted to simple whole number. That is the rule of empirical formula. That is the rule of empirical formula. Now, you have seen how the thing is being solved. So if they give you a question like this, you must have to look for the mass of this, of the next element that is not being given in grams. Then find the percentage before you start solving the empirical formula. Then when you start solving the empirical formula, you follow the rules of solving empirical formula. Now the next one is formula mass. Formula mass, the formula mass of a substance is the sum of the atomic weight of the atoms in its empirical formula. It is expressed in atomic mass unit. I told you what atomic mass unit already, so you know that. Now, we've gotten our empirical formula. Okay? Now they say the formula mass of a substance is the sum of the atomic weight. The sum of the atomic weight. When you sum the atomic weight together, it gives you the formula mass. When you sum the atomic weight together, it gives you the formula mass. In essence, it is being gotten from an empirical formula. It's being gotten from an empirical formula. Now, we've gotten this. Okay, we've gotten this. Let's just see what the thing is talking about. Formula mass. Now remember, we solved an empirical formula question, which gave us an empirical formula of H2S which gave us an empirical formula of H subscript 2 SO subscript 4. Okay, we solved an empirical formula. And I said the formula mass of a substance is the sum of the atomic weight. In essence, the sum of the atomic mass of the atoms in the empirical formula. Now, we've gotten the empirical formula as H subscript 2 SO subscript 4. We solved something like this. We solved something like this. Okay? Or let's use the last one we used. Let's use the last empirical formula, which is this. This is the last one we just solved. Okay? Now, the formula mass of this is very simple. If the mass number of an element is 16, the formula mass will still be 16. Okay? Now, they say the formula mass of the substance is the sum of the atomic mass. The sum of the atomic mass, remember I said nitrogen is 14 and magnesium is 24. Now, the formula mass will be nitrogen, the mass of nitrogen is 14, plus the mass of magnesium is 24. Remember, magnesium has 2 atoms. So it will be 24 times 2, which is 48. So the formula mass will be 14 plus 48, which will give us 1262. Formula masses are being gotten from empirical formulas. And this we just solved now. We just solved an empirical formula that gave us this answer. Now, from this empirical formula, we'll get our formula mass. Because they say the formula mass of a substance is the sum of the atomic weight. Atomic weight is still almost the atomic mass of the atoms in this empirical formula. The empirical formula, now nitrogen has 1, which is 14. So it's 1 times 14. That's a 1 times 14. You can still put 1 times 14 plus 24 times 2. Magnesium has 2 atoms. So it will be 2 times 24. Because the mass number of magnesium is 24, it gave us 48. So it's 14 plus 14, 8, give us 62. This is the formula mass. It must have to be gotten from empirical formulas. We did another question that gave us an empirical formula of H subscript 2, SO subscript 4. The same thing applies to this. The same thing applies to this. You calculate for hydrogen, you calculate for sulfur, and you calculate for nitrogen. You calculate for hydrogen, calculate for sulfur, calculate for oxygen. When you calculate all these masses together, they're going to give you the formula mass. Okay, they're going to give you the formula mass. Now, difference between empirical and molecular formula. Empirical formula represents the simplest whole number ratio of atoms in a compound, while molecular formula shows the exact number of atoms in the compound. Now, the empirical formula, like I said, is a whole number ratio. If it's in decimal, you have to convert it to the simplest whole number, to the nearest whole number, like I said. But if the molecular formula shows the exact, you do not have to convert. Like this now, it is an exact. H subscript 2, SO subscript 4. This is the exact number of hydrogen. The exact number of hydrogen is 2. The exact number of sulfur is 1, and the exact number of oxygen is 4. But when we solve the empirical formula, the exact number of solved oxygen was not 4. The exact number of oxygen was 3.9 something. Okay? We had to convert it to the nearest whole number that gave us 4. Now, this 4 became the exact number of the oxygen in the compound of H subscript 2, SO subscript 4 with the sulfuric acid. Now, these exact numbers are the molecular formulas, while the conversion of the whole number to the simplest way is the empirical formula. Now, the similarity between empirical formula and molecular formula, they both show number of atoms in a compound. Yes, they both show numbers. Okay, when we solve the empirical formula, we saw numbers, integers. It shows that this number is the number of atoms that this particular element is given. The molecular formula too is showing us that hydrogen is given 2, sulfur is given 1, and oxygen is given 1. So we've come to the end of this section. But before we go, we use our exam guide to quantify what we have learned so that you'll be able to understand what you've learned today. Now, the organic compound contains 40% carbon, 6.7% hydrogen, and 53.7% oxygen. What is the empirical formula of the compound? What is the empirical formula of the compound? What is the empirical formula of the compound? Remember, the first one is change percentage to grams. Change percentage to grams. Change percentage to grams. Change percentage to grams. Okay. Now, an organic compound, let's go. Okay, let's go to the exam guide to quantify what we have learned. To quantify what we have learned. Now let's go to the exam guide. We'll go to 2010, question 44. Question 44. It says an organic compound contains 40.0% carbon, 6.7% hydrogen, and 53.3% oxygen. What is the empirical formula? Remember, the first step of solving, I told you that when they give you this empirical formula question, they're going to bring out the molar masses. They're going to bring out the mass numbers so that you'll be able to use it to solve. They gave you oxygen as 16, carbon as 12, and hydrogen as 1. Now, the first step, they say change percentage to grams. You already know that solution. Change percentage to grams. So, we are changing the percentage of carbon. They say carbon is 40. Contains carbon. Carbon is 40. Okay? 40.0. 40.0%. Then they say that hydrogen. Carbon is 40.0%. Hydrogen is 6.7%. And oxygen is 53.3%. Step 1. Now you're changing the percentage to grams. That's the first step, remember. It will be just 40.0 grams, 6.7 grams, and 53.3 grams. The second one says divide all by their molar masses. Divide all the elements by their molar masses. Remember using the empirical formula rule. Divide all the elements by their molar masses. And they gave us their molar masses as oxygen as 16. Okay? Carbon as 12 and hydrogen as 1. So carbon, step 2, carbon will be 40.0 divided by 12. Okay? Divided by 12. Carbon will be divided by 12. So when you see carbon, they say 40 divided by 12. Okay? And it gave us 3.33. 3.33. Then hydrogen is 6.7 divided by 1, which is 6.7. That is the molar mass of hydrogen. Okay, 6.10. 6.10 is still the same as 1. Then oxygen is 53.3 divided by 16 that they gave to you. 53.3 divided by 16. It's 3.33. 3.33 again. Okay, 3.331. 3.33, 3.33. Now, what did they say? They say, now, we've gotten step 2. Okay, we've gotten step 2. Now, step 3 says, divide them by the smallest number. Okay, the smallest number, we have 2 numbers that are smallest, so use 1 and divide. You have 2 numbers that are smallest, so use 1 to divide. Okay? You have 2 numbers that are smallest, so use 1 to divide. So step 3, they say divide them by the smallest number you've got from the previous step. Now, carbon will be equal to 3.33 over 3.33, which is equal to 1. Hydrogen will be 6.7 over 3.33, which is equal to 6.7 divided by 3.33. Which is equal to 2.01. Then oxygen will be equal to 3.33 divided by 3.33, which is equal to 1. So we got 2 smallest numbers, 2 numbers that are smallest, but it doesn't mean you pick one of them and do the division. As long as they're the same, it is the smallest number. The number is the smallest number. Then they say the coefficient you got becomes the subscript. The coefficient you get becomes the subscript. Step 4. We got carbon as 1, hydrogen as 2.01, and oxygen as 1. Now, there's a rule again that you know that says if it's in the decimal, you convert to the nearest whole number. In essence, hydrogen that has 2.01 will be converted to the nearest whole number, which will give us 2. So in essence, hydrogen becomes 2, carbon becomes 1, and oxygen becomes 1. So now, the subscripts there, step 5. Step 5. Now, the subscript there, 1 is already 1. You do not write 1 as a subscript. Okay? Do not write 1 as a subscript. So the answer there will be C. The carbon is 1 as a subscript. The H is 1, and the oxygen is 2. This is our answer. If you check, sorry, the H is 1, sorry. The C is 1. The C is 1. The H is 1, and the oxygen is 1. So the answer is, if you check, look at the board, okay? The C is 1, the H is 2, and the oxygen is 1. The H is 2, the oxygen is 1, and the carbon is 1. So in essence, they say the answer you get, the coefficient you get, becomes the subscript of the element. In essence, the element H has a subscript of 2, the element C has a subscript of 1, and the oxygen has a subscript of 1. You do not write 1 as subscripts. They don't write 1 as subscripts. Okay? Subscripts start from 2. So if you check, the answer is CH subscript 2O. CH subscript 2O. So the answer is C. CH subscript 2O. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.